ellipse. So what you're going to see is two equations. I don't want you to get hung up. Now, you've already seen these because, well, hopefully you've seen them. You did the Desmos exploration, right? So hopefully you've solved these before, but I don't want you to get hung up on A's and B's. Because if you get so involved in the formula, you don't really understand what's happening here. Okay, so this will talk about things with A's and B's, but when I just think about it, I'm just thinking about the number quantity that's sitting there. Like if A squared is 100, I'm thinking about 100 and I'm thinking about 10. I'm not thinking about, when we look at these two equations, one of them has A under it and one of them has B under it. I'm not really worried about that. If you are a formula person, you cannot function without a formula. That's a lot to memorize, but you can memorize. But for me, I'm going to just think about what the math does, and then I don't have to memorize as much. You do need to memorize things like this equation equals 1. It does not equal radius squared like circle does. So you do memorize that. You need to memorize things like the top part of the equation is exactly the same as the circle. It's going to give you your center. HK is your center. People will make oopsies, mistakes. Nope, they won't on this one. I lied. That's the next section. There are two different axes. So when I make an ellipse, there's how far do we go out from the center horizontally and how far do we go out from the center vertically. The axis that we call the major axis is the bigger one. The one that we call the minor axis is the smaller one. Your book will sometimes use words like, well, when we talk about the end points of the major axis, we call them vertices. And some books will call them major vertices. Some books will just call them the vertices. The minor axis, the end points. Sorry, these are the end points. The endpoints. But for the minor axis, the endpoints could be called minor endpoint, minor vertices. Sorry, I couldn't remember. Minor vertices, or they might be called co-vertices. So in the book, they're like called one thing. And then in a worksheet that I have, they're called the other thing, but it's the same. Minor or co are the ones that are not the major ones. Vertices would be the major ones. If they have the extra co, they're not the major ones. The foci have a distance of C, so we've got another letter involved, C units, but we get that C units by using something that looks like the Pythagorean theorem but isn't. So we've got A squared minus B squared equals C squared. So this is not the Pythagorean theorem. If you use A squared plus B squared equals C squared, you're going to get it wrong, and you're going to be like, what's wrong? I don't know what I'm doing wrong. Like, you should know if it's wrong. It's not going to work right. The foci are always inside the ellipse. So if you use the wrong formula, your foci will end up outside of the ellipse, potentially. So they're always on the inside of the ellipse. The length of the major axis, the total length is 2a. That means there's two parts of that major axis that are A and A. The length of the minor axis is 2b. So that means there's two parts of that minor axis that are each b. I add the full b and b together, we get a length of 2b. Okay? So we are going to graph an ellipse and state all necessary information. In order to graph this and state all the necessary information, it has to be in the correct form. Nairi, is question A in the correct form of the standard graphing form of an ellipse? Where's the minus sign? In the standard graphing form? Okay. Are they the same, Nairi? They don't look the same. Who can point out one of the major, Brandon, what do you see? That's not right. It doesn't equal 1. That's exactly what I'm looking for. John, I might have more. Here. That's just one quadrant. I mean, you can use that if you prefer, but. Right, it doesn't equal 1. So if you do not have the correct format, you can't start finding this information. So the first thing I'm going to do is put this in the correct format. To make it say equal 1, I got 2 choices. I could either subtract 8 or divide by 9. When we look at this equation up here, there's division in it. So I'm going to divide by 9, everything. Now, this is in the correct format. I did not put the y squared over 1. However, I'm going to put the y squared over 1 to help all of you learn this because it's new. If we have a Canvas form where you have to fill stuff out, I will have you type that 1 in. Okay? But you don't have to put the 1. Just want to let you know, you don't have to put that 1 underneath the y squared. So now what we do is we're going to find our center. And our center is hk. But if it's just x squared and y squared, what are the h and k values? John, what's h and k? H and k is subtracting or adding from the x and y. And then squared. But this is just x squared. So what's h? It's just x squared. It's like 0, yes. And what would k be? Also 0. It's not like 0, it is 0. So 0, 0 would be our center if there isn't transformations with the squared. Okay, so I'm going to go ahead and graph 0, 0. Okay, the next thing is major vertices, minor vertices. So just a reminder, if you see it worded differently, it might just be vertices and co-vertices. Either is acceptable. Just want to remind you guys that they're both ways. Okay, so to find the major vertices, we're going to look at what's underneath the x and y squared. Oh, there we go. We're going to look what's underneath the x and y squared. So underneath the x squared is 3 squared. Underneath the y squared is what squared? 1 squared, okay? In the formulas, it has like a squareds and b squareds. So a is the bigger one. Which one's bigger? A is the bigger one. Which one is A? The 3? 3 squared. 3 is the A. A would be 3. So that means B would be 1. So A is bigger. It comes first alphabetically. That is the one that determines our major vertices. So what I now have to do is say, what is the bigger number under? Bigger number's under X. So that means that I go to my graph and horizontally, I'm going to add 3 in each direction. Why did I do it horizontally? Because it's under X. So the number it's under is telling me which way to go. Or the letter it's under, I should say. The variable it's under is telling me which way to go. Now, you're going to write the endpoints on this line. So there's 2 ways we could get the endpoints. Way number 1, look at the graph. We just plotted them. Way number 2 would be to take your center, and we added and subtracted 3 to the center to the X values. So way number 2 would be to plus minus 3 to our center point. So you got two different ways of finding those ordered pairs. You choose. When we type them in Canvas, which we will eventually do, you're going to put the smaller one first. So it's good practicing that now so you don't find out on a test that you didn't know what was expected of you the whole time. So just put the smaller one first every single time. Okay? All right. Minor vertices or co-vertices would be the other value down there. So it's a 1. 1 squared. B is a 1. And that is under the Y. So because it's under the Y, to the ordered pair, I'm going to plus minus 1 to the center ordered pair. I'm going to plus minus 1. I'm not going to go off the major vertices. I'm going to go off the center. So my 2 points will be 0, -1, and 0, 1. I can also go to the graph and graph 1 point up and 1 point down from the center point. And then just write down those points. But again, we're going in order, so you put the -1 before the +1. So now we get to foci. So the foci equation from above is a squared minus b squared equals c squared. If you do this equation correctly, it doesn't even matter if you know which one a and b is. If you subtract them in the wrong order, you're going to have to take the square root of a negative number, and we don't do that. So you have to do the big one minus the smaller one. It doesn't really matter if you know what's a or b. So I'm going to do 9 minus 1. So I get 8 is c squared. Now we have to solve for c. So I will square root both sides, and it will be a positive answer. Actually, it's going to be plus minus. It will be plus minus, but you don't necessarily have to write it right now. If the square root of 8 can be simplified, it has to be simplified or you will lose points. So can square root of 8 be simplified? Yeah, by what is it going to be? 2 radical 2. So that's my c value. Now the foci, they go on the graph in the same direction, on the same axes that is major. So they only go on the major axes. They go on the same direction as the longer ones. So what we have to do is we have to start at our center again and add and subtract 2 radical 2 to the x value for this one. It would be y if it was like longer the other way. So my foci points will be -2 square root 2 comma 0 and +2 square root 2 comma 0. Hey, Brandon, do you have an approximation of how long square root of 8 is without using your calculator? Yeah, you got an approximation. Square root of 8. Square root of 8 is how long? Nope, I'm gonna call on somebody else because last time you were like talking about the circle and you seem to have like really good understanding. But I know Anthony's the one I called on before. Anthony, do you have an approximation?
Probably like 2.6 or 7.
Okay. 2.8. A little bit further, because what's the square root of 9? 3. So it's got to be just under the square root of 9. You don't have to use this approximation. I just thought I'd throw that out there because you guys were doing that really good last time. It's about 2.8. We really can't graph any more accurate than 2.8. It's barely even hard to graph 2.8 as accurate. But when you go to graph it, you can find the decimal approximation. Where did my others? I'm going to zoom in really far because how accurate can I really be? Okay. And then the last thing we're going to do, and we did this last time, is I'm going to use I didn't do it with a straight line last time. I'm going to do it with a straight line this time. I'm going to use a straight line, and I'm going to make a rectangle that goes through those vertices. And that's going to allow me to connect my ellipse much more accurately than just trying to freehand it. I mean, try to freehand it. They don't usually look really good. But I'm going to use this corner as helping me round it out. And that way, if I mess up one of the corners, I can just redo that one corner instead of the whole thing. I think my first one was rounded too much. It's a little bit better. There you go. Degrafted ellipse. That's not too bad. Let's look at the next one. So the first question you need to ask yourself, is it in the correct form?
Yes.
Yes. Does it equal 1? Yes. Okay. So we are going to find the center. Same way we find the center with the circle. Kira, can you tell me the center? 1, -3. Perfect. I'm going to go to my graph, and I'm going to graph 1, -3. There's my center point. Now my A and B values, again, it doesn't really matter if you're using A and B or X or Y, or doesn't matter. We have to square root each of these numbers because these are the A squared and the B squared numbers. So this one is 5 squared. This one is 6 squared. Which one's bigger? Okay, so A is 6. B is 5. A is underneath the Y. So that's telling me that my major vertices are going to be the Y's, up and down vertical. So if I'm using my ordered pair, my center, I will plus minus 6 from -3. Or you could go over and count up 6 and down 6 from your center and write down those ordered pairs. I don't care which method you choose for finding the ordered pairs. Just put the smaller one first. Oops. So I got 1, -9, 1, 3. And then the minor vertices, we're going to add and subtract 5 from the x's. The foci, you're going to do a squared minus b squared equals c squared. So I look at 25 and 36 and I subtract them. They have a difference of what, Marie? 11. So c squared is 11. C is square root 11. Because my major vertice went to the y values, my c's plus minus square root 11, they also go to the y values. I'm going to put the one with minus square root 11 first, because that is the smaller one. Caleb, did you already type in square root 11? If so, don't. Can you approximate it for me?
I think it's about 3.2.
You're close. It's a 3.3. 3.3. Just curious. That's fun to do. It's like a guessing game. That's like guessing how many jelly beans are in the jar, right? It's about 3.3. So when I graph it, you know what? If you graphed 3.2 and I graphed 3.3, nobody's going to be even able to tell the difference. So I'm just counting it out. 3.3, approximated 3.3 for my foci. Okay, then I'm gonna use my drawing or my shapes, and I'm gonna make those rectangles so that my graph isn't completely ugly. Just give me some guidelines to follow. Yeah, that was so ugly. A little bit better. Okay, I have slight need to have perfection in my drawings. Okay. Any questions about this so far? Okay. So is question C in the correct form?
No.
Okay. What are we going to have to do to put it in the correct form? Any guesses? Subtract 84? Yeah. Yeah, we got to do that. All right, I subtracted 84. Any other guesses of what we're going to have to do to put it in the correct form, Caitlin?
Complete the square.
We're going to have to complete the square. Can I complete my square with 16x squared plus 96x as is? What do I have to do, Lydia, to complete the square with the 16x squared plus 96x first? I need to factor out that 16. So I'm going to have 16 parenthesis x squared plus 6x plus fluffy cloud parenthesis. With the y's, can I go ahead and complete the square or extra step, Lena? What do I need to do? Okay, we're going to factor that 4 out. I forgot to put in a square for my y's. Factor out that 4. Put that in front. Left with y squared minus 2y plus my fluffy cloud. Okay, the more you practice the complete the square, you'll notice that the same numbers just keep coming up over and over again. So eventually you won't even need to put in b over 2 squared like on your paper. Like right now, I don't need that. Do we know what goes in my fluffy cloud in the first one? 9. What goes in the square in the first one? It is 144. How did you get 144, Brandon? Right. So we took the 16 out, and then we had the 9, so we got to put the 16 back in, 144. Okay, and then the second one, does anybody know what goes in that one? Just in the inside? 1. And then I'm going to put it back, put the 4 back in, so it's 4 that gets added to the other side. So I've got 16 parenthesis x plus 3x, or sorry, plus 3 squared, plus 4. And then for this one, just be careful that you don't forget that it is a negative 2. So we have to have minus 1 squared when we factor it. And then on the other side, I get 64. So is this in the correct form? Daniela, are we ready? Like, is this in the correct form? For the formula? What do we have to do with the 64? Divide by 64. Yep. So it needs to equal 1. It does not equal 1 right now. So we're going to go ahead and divide everything by 64. So I get x. This is not going away. I get x plus 3 squared on top. And then when we reduce 16 over 64, I get 4 left over on the bottom. Plus y minus 1 on top. And then 4 over 64 is 1/16. So I get 16 on the bottom equals 1. What's up, Connor?
Did you factor that on 4 at the beginning?
Yeah, we could have divided everything by 4 at the very beginning. Now, some of them you won't be able to do that with. So I want to practice what's going to work with all of them. But yes, you could have done that if you noticed that ahead of time. That was a good question. Thank you. Okay, so what is our equation? We've got, I already wrote it, but I'll read it again. Write it again. X plus 3 squared over 4 plus y minus 1 squared. Oh my gosh, it's way too messy. I can't. Y minus 1 squared over 16 equals 1. Okay, so Connor, where is our center? Good. I'm going to go graph that. -3, 1. Got my center. So now looking at the bottom values being the a squared and b squared, doesn't really matter which one's a or b. 4 is 2 squared. 16 is 4 squared. So one of these is going to be 4. One of these is going to be 2. Which one is the a squared? It's the bigger one. So what's a? No, that's a squared. What's a? 4. Okay, so then b is 2. But again, it doesn't really matter because once you graph them, you can tell which one's the major. What's that?
On like the test or whatever, you're not going to make any of them like to where the denominator doesn't come out to like an even number, right? Like a whole number. Like you wouldn't have one of them be like 11.
I won't say that I won't do that. Probably not on a test.
Okay.
But I won't say that you won't have homework like that.
Oh, yeah.
Yeah. So if it comes out to be like square root of 11, like we had for foci, you would just decimalize that, and that's how you plot it.
Okay.
So the fact that I'm showing you how to add with using the ordered pairs, that's what you would need to do if it doesn't come out as a nice number where you could count and say, oh, that's sitting at 6. You'd have to say over here, you'd have to be like, okay, well, I know it's going to be on the y side, and I've got a plus minus 4 to the y side, but it might be like square root 11 that you're doing. So that would be the only more challenging part, was you couldn't use the graph to find the ordered pair. Okay, so my major vertices will be at -3, 1, minus 4. Oh, why am I doing that? Because I'm talking to John about that. 1 minus 4 is what? -3. And then -3, 1 plus 4, 5. And then the minor vertices will plus minus 2 to the x's. And I get -5, 1, -1, 1. Okay, and then we just have our foci. And if you don't remember what A or B is, you got to subtract them so they come out with a positive answer. So the only way I can subtract to come out with a positive answer is 16 minus 4. I get square root of 12. Is that simplified? No.
Yeah.
No.
Wouldn't it be 3 squared?
2 radical 3. 2 square root 3. Mark. Approximate square root of 12, unless you've already typed it in. It's just for fun. What'd you say, 0.5? Let's see. I don't know. It is 3.46. So, yeah, about 3.5. Good. So our foci, because our our ellipse is longer vertically, I will take that square root or 2 square root 3 and add it onto the vertical part of the center. Plus minus 2 square root 3 onto that 1. So I will have negative 3, 1 minus 2 square root 3, and negative 3, 1 plus 2 square root 3. And then when I graph it, I'll just use about 3.5 from the center. Well, I guess this one's going to be pink. Where can you guys go to make sure that you didn't just royally mess that up? Can you type this equation into your graphing calculator? Do you know how? What does every single thing that we type in our graphing calculator to be graphed have to have in common? Has to say equals y. So yes, it is possible you can type this into your graphing calculator to check your answers. However, you'd have to be able to correctly take that equation and solve it for just y, which is doable, but it is, if you're really that unsure about if you're doing it right, you have to be really good at your algebra to solve that for y correctly. So there's a little shorter way of checking, and that's just typing it in Desmos. In Desmos, you don't have to solve it for y, but you don't get Desmos for a quiz or test. So if you're going to use this check, you're going to use it to make sure you're right and that you understand the content. You're not using it to get your answers because you don't get that on a test. Got it? And if you're seriously going to learn how to type it in here, then you should just learn the content because it'll be less work. Wow. You mean check by plug in a point that you found? Possibly. But there could be like a point that works, but not all the points work. So could you maybe check all 4 points? Yeah, the vertices you could check with, but that's again really time consuming. So, but yeah, you could do that. Okay. When I give you a quiz or test on this stuff, I won't have you graph it. I'm just going to have you find this information and type it in. Okay. All right. How about you practice? I'm going to pause the video. You practice completing the square and see if you can get this equation correct. All right. So I'm going to complete the square. And I'm going to rearrange this so that my x's are together. And then my y's And then I'm going to move the 76 over, minus 76. I'm going to complete my square with my x's, with my y's. I always write those silly looking squares because if I don't, sometimes I forget. And then I spend like a bunch of time, I waste my time saying, what did I do wrong? So now I put them in. Then I'm taking the 25 out because we can't have that to complete the square. And as I do that, I'm also figuring out that a 4 goes right here. And then the y squared, there isn't anything to take out. So that is a 1. And then for my pink one, 25 times 4, I put 100 on both sides. And then I'm going to factor. And I get 25 on the right side. So then I'm going to have to divide everything by 25. And I will get x minus 2 squared over 25 plus y minus 1 squared over, I messed that up. First one's over 1, second one's over 25, and then equals 1. From there, we can find our center to be 2, 1. I'll go plot that. My major vertices, I'm going to be adding and subtracting 5 from the y values. My minor vertices, I'm going to add and subtract 1 from the x's. And the foci, I'm going to subtract the 2 numbers and then square root. And square root of 24 does become 2 square root 6. Sarah Nold, what do you think 2 square root 6 is? Or did you already look? Did you already type it in? Okay. What do you think it is about?
I don't know how God this already.
Let's see. Well, square root of 24 is close to what perfect square?
Yeah. So maybe like 4.8.
4.8-ish? Let's see. Maybe? It's probably pretty close. Square root 24. I mean, how accurate can we graph? It's 4.89. So it'd be more like 4.9, but that's still pretty close. That was your ish that you were talking about. So it's almost 5, but not quite 5. So I will add my foci to the y's because that we add to the same one that we did our major, our bigger number. So I'm adding plus minus 2 square root 6. And then once I have all that information down, I can graph it. So what was I going? 5 and 1. Oops. What did I just... Oh my gosh, I got to talk to you guys about that. Not this second, though. So that foci, I can't even graph that accurate. It's basically on that point that was already there. What do you think makes the ellipse so skinny? What do you think?
It's tall on one side and one side.
Well, yeah, but what about the equation makes it so skinny? Is it because 25 is such a big number?
This one is small.
Is it because one is small? What's making it so skinny? What? Yeah, but what about the A's and B's is making it so skinny? Be more
The A is
exact.
under the Y.
The what?
The A is under the Y equation. Or like A.
Like, why was this one so skinny, but the one we did before, actually go back to question B, was so fat? B had bigger numbers. Connor?
The difference between A and B is
The difference between the A and B's is what's going to determine if it's skinny or fat. You see, with B, we're going from like 5 and 6. But with question D, we're going from 1 to 5. Well, that's a bigger difference. So good job. All right, let's take a quick break and then we'll finish up our last examples are finding the equation with given information. So this is telling us that our foci are at 5, 4 and negative 3, 4. And the major axis is 10 units long. Some people are visual. For example, I am fairly visual. So if you are that visual person, maybe it helps to plot it. Maybe it doesn't, but to me, it helps to plot the information. You do not have to. If I have foci at 5, 4 and negative 3, 4, what is that going to help me find? Or maybe I should word it in a different way. What do I need to find to write the equation of the center? Will these foci help me find the center?
Yeah.
Where is the center with these foci? The middle, the midpoint. Average them, figure out the middle. If you graphed them, you could count and figure out the middle, but I'll just do it mathematically. So 5 plus negative 3 divided by 2. 4 plus 4 divided by 2, that number didn't even change, right? The y value didn't change. It's only the x's. So really, I only have to midpoint once. What is that? 2 over 2, 1. So 1, 4 is our center. So far, my equation is going to be x minus 1 squared over something plus y minus 4 squared over something equals 1. That I know for sure. So now we got to figure out our a and b squareds, a squareds and b squareds. So another piece of information it tells us is the major axis is 10 units long. The major axis is on the same axis with the foci. So from the center, if the major axis is 10 units long, that's the total. How far is one side? 5. So from the center, if I'm going 5, 1, 2, 3, 4, 5, or the other way, I just actually found 2 pieces of information. I found that my a value is 5. So my a squared is, actually I found 3 pieces of information. A value is 5, a squared is 25, and I also figured out something about where the a squared goes in the equation. It goes on the x because I'm going horizontally. Another, when I was counting out the 5, I figured something else out as I was counting the 5. Did anybody figure out something else when they were counting the 5?
The C value.
The C value, what'd you get? Okay. So then I know the c squared is 16. That's not what goes in my equation though. But if I know a squared and b squared, I can say a squared minus b squared equals c squared. So 25, take away what number is 16? 9. So now I know my b squared is 9. It doesn't even matter that b is 3. I just need to define b squared. And I have my equation. That's it. To check your answers for this, you could use Desmos, graph that, and make sure that the graph looks correct. But unfortunately, like, you won't be able to check up and down because it didn't really tell you information about that. And Desmos won't graph the foci for you. Oh, bless you. Okay, let's look at B. Actually, I'm gonna give some silence. I'm going to graph it up here, but I want you guys to start thinking about what we just did on A and see if you can pull out any information on your own in B. And then I'll talk. Belle, were you able to find any information yet? Mm-hmm. What is the center? You guys agree or disagree with Belle's answer? Agreed. Good. So right now I can go ahead and say, well, it's going to be x minus 4 squared over something plus, ooh, how do I write y minus 0? No, just y squared. Thank you. Over something equals 1. I am not going to make y minus 0 an option on Canvas. If you type that in, it's going to mark it wrong, and then we'll have to go fix it. I will fix it. Don't type in y minus 0. That's not, like, simplified. Okay?
Is it, never mind. Wouldn't be 13 squared under, what is it?
Okay, I'm going to talk about what you're saying about 13. You're talking about 13 being one of the variables, either A or B. Do you know which one it's going to be, A or B?
It's gonna be, it's gonna be,
The major is A.
oh, it's gonna be it,
Right.
under the Y.
And why is it going to be under the Y?
Because it's under the Y, like, part of the coordinate.
Because the major vertices go up and down. Yep. So A is 13, A squared is 169. Okay. So what else can I pick out from the graph? Nick, what can I pick out? Or are you following? Do you know what else I can find from the graph? I didn't know if you were following because you weren't. Okay. Daniela, can you tell me something else I can pull from the graph? I got my A value. What else can I get? What gives us, Daniela, what gives us these guys? Okay, so C value would be how much? 12. So C squared, 144. So if we do A squared minus B squared equals C squared, 169, take away what number equals 144?
25.
25? Then that's got to be the missing one. Okay, center at 5,4. Our major axis has a length of 20 and is parallel to the x-axis. The minor axis has a length of 12. So on the first page, the major axis length was 2a. So if we know the axis is 20, what is my a value? 10. The minor axis is 2b, which is 12. So b is 6. We need a squared and b squared. So I have x minus 5 squared, and I have y minus 4 squared equals 1. But we got to figure out what goes under what. It says that the major axis is parallel to the x-axis. So I'm going to go over here and sketch. Here's my major axis. Which variable is the a squared going to be under? The axis. All right, this last one. I can see the center point right now. I don't have to do any math. I can see the center point. It doesn't say here's the center point, but I can see it. Does anybody else see it? I can see the center point right now, and I don't even have to do any math. I don't have to average anything. Does anybody else see it? You see it, Mark? Maybe. I know, I see you. Who thinks they see it? I'm not going to call on you just because you think you see it. Brandon, where do you think it is? It is at negative 2, 2. Where do you see that up here? Okay, so that's not where I got it. I can literally see negative 2, 2 sitting up there. Lydia? Yep, you got it. On the foci, we got to add and subtract a value to get the foci. This foci, the c value, is 3 square root 3. So when I add and subtract that, it doesn't combine with the 2. So I can like see my center right now. I didn't even have to do math. So my center is at negative 2, 2. So x minus, nope, plus 2 squared over, what am I doing? Y minus 2 squared or something equals 1. So now, so far, I've got that. We know that our c is 3 square root 3. That makes our c squared 3 times 3 times 3, 27. We either need to find our a or our b to use with c to find the missing one. So it says the major axis endpoints are at 2, 8 and 2, negative 4. If I talk about negative 2, and I said 2, I meant to say negative 2. Negative 2, 2 being the center of those, how far apart are they? 6 apart, right. So our a value is going to be 6. So a squared is 36. Which variable changes? John, which variable is changing here? It's the y. So that 36 is under the y. And then we'll do a squared minus b squared equals 27. So it'll be 9. Good. All right, that's it for notes for today.